Very good morning, everyone. Today's topic is non-deterministic finite automata. It is commonly called the NFA. Is an important concept in automata theory that helps us understanding how a machines can process input strings in a flexible and powerful way. So the term non-deterministic means the system does not follow just one find path. So instead of it it can have a multiple possible choice at each step. In traditional systems like deterministic finite automata, for every state and input symbol, there is only one possible to the next state. But in an NFA, for a given state and input, there can be more than one next state. So, or even no transition at all. This means the machine can explore the different paths simultaneously. Formally, an NFA consists of a finite set of states. So the input alphabet, the transition relation, an initial state and a set of final states, etc. The key difference here, the transition relations, which allows a multiple outputs instead of a single definite output. And another powerful features of a NFA is the presence of epsilon transition, that also known as the epsilon moves, where the machine can move from one state to another without consuming any input symbols. In this situation, this adds more flexibility and makes their design of multiple automata similar in many cases. To understand this better, let us consider an example where we want to check whether the string contains or a pattern. The pattern should be it is a numerical pattern. That pattern should be 010 or 0101. Suppose the input string is 0101 in an NFA. When the machine reads the first symbol of a 0, it does not need to immediately decide whether this is the start of the pattern. Instead, it can be branched into a multiple paths. One path may assume that this 0 is the beginning of the sequences 0, 1, 0. The another path may ignore and it wait for the better match later. And yet another path may explore the different possibilities. As the input is processed, each of these continues independently. The diagram shows the how 0 and 1 will be calculated into the non-deterministic finite automatas. If the string can very important of the beginning of a sequence, the another path may be ignored. The ignoring path may consider into the better match of later. Yet another path may explore the different possibilities. As the input is processed to each of these paths continuously independently, then the end of the computations, if at least one of these paths reaches a final or accepting state, then an entire string is accepted by the NFA. So this is a very important concept. Unlikely deterministic finite automata. Deterministic finite automata also a very important concept where only one computation path exists. In NFA, we have a multiple computations happen in parallel and success is determined if only one path is succeed. Even if many path fails, a single successful path is enough for acceptance. So this behavior can be compared into the real life situations where the person is tries multiple strategies and move on to the next and end. In the situations we move one after the another. the same time to solve a problem, and if any one strategy work, so the problem is considered to be solved. uh, Considered to be solved because of this ability to explore the multiple possibilities simultaneously. The NFA are often easier to design a DFA for a certain problems, especially when dealing with complex pattern matching. However, it is also important to note that for every NFA, there exists an equivalent DFA that recognize the same language, although the DFA may have more states. This shows that both models have the same computational power, even though their working style are different. Style are different. For the example of an NFA for accepting all the strings matches. In the summarized version of these NFA, uh, flexible computational model that allows a multiple transaction for their single input, support epsilon moves, and accept a string if at least one computation path leads to final state, making it a powerful and initiative concept in a study of formal language and automata theory. Thank you.